Now I'm going to do a form of elimination that is talked about in chapter 10.3 of your book. We're not going to cover it officially in class, but I want you to see it because I'm guaranteeing that you will see it when you reach the higher levels, calculus, linear algebra in particular. I remember when I saw this the first time in what was called then Math 238 at NAU, and it was linear calculus and linear algebra, and this was the very first time I saw it, and I took about 2 weeks of struggling to get it. I hope that my little demonstration here will help you avoid the 2 weeks of struggle later on. So here we go. I have this system of equations right here. And what the Gaussian reduction or Gaussian elimination, or it's also called Gauss-Jordan elimination, what this does is eliminates writing the x's and y's, and all we do is write the numbers that are the coefficients to those. And we make what's called a matrix out of it. A matrix is an array of numbers. And so I'm going to do that, and I'm going to start. I like to make these little brackets, and I'm going to go 2, minus 3, 10, 4, minus 1, 10. Then I'm going to close it with another bracket there. What I've done is I've just taken the numbers that are in front of x and y and this number that's on the other side of the equal sign. 2, minus 3, 10, 4, negative 1, 10. What I'm going to do first is I'm going to try, here's what I want. This is what I want it to look like at the end. I want it to look like 1, 0, and some number. And then 0, 1, and some other number. This basically says that x is equal to this, and y is equal to this. So this is my goal. This is the reduced row echelon form, but I don't care about that name, and I don't want you to either. I just want you to know that I'm gaming for this. So my first step, I'm going to multiply this by negative 2, this line by negative 2, and I'm going to write it down below here. And I'm going to have a negative 4 and a plus 6 and a minus 20. I'm going to add those, and I get 0, 5, negative 10. So this tells me, now I'm going to go over here. This is a new matrix that I'm writing, and I'm going to write my original first line, 2, minus 3, 10, but now I have this, which if I multiply through by a 1/5, I'm going to get 0, 1, minus 2. This tells me right now that y is equal to negative 2. But now I'm going to get rid of that other term by multiplying this one through here by a positive 3. 3 times 1 is 3. When I add these equations, that y term is going to drop out. So I do that. I have 3 times 0 is 0. 3 times 1 is 3. 3 times negative 2 is negative 6. Now I'm going to add, let's draw my third matrix here. I'm going to add these two, and I get 2 plus 0 is 2. Negative 3 and 3 is 0. 10 and minus 6 is 4. I'm going to bring down this one here, 0, 1, minus 2, and I'm almost done. All I'm going to do now is multiply this first one through by 1/2, and I get my final 1, 0, 2, 0, 1, minus 2, and this is what I wanted to see right here. 1, 0, 0, 1. I've got it. So this means that x is 2 and y is minus 2. Now let's check. If x is 2 and y is minus 2, is it true that 2 times 2 is 4, minus 3 times a negative 2, which is plus 6. 4 plus 6, is that equal to 10? Yes. Now bringing down here, 4 times 2 is 8, minus a negative 2 is plus 2. 8 plus 2, that's 10. Yes, the answer is worked. So my answer using Gaussian reduction, Gauss-Jordan elimination, whatever you want to call it, is 2 minus 2.